Sol gel method, the different steps which are involved are hydrolysis, condensation, liquid sol formation, gel formation, aging, drying, and sometimes calcination. So we'll look into these different steps one by one. So the first step is formation of sol. Here uh, the solid compound, the material, is dissolved in a suitable liquid, that is either water or a solvent, to bring it back in the form of a nano material in a controlled manner. So sol is nothing but a stable dispersion of colloidal particles or polymeric material in a solvent like alcohol. The particles may be amorphous or crystalline. In case of silica gel, we use the tetraethyl orthosilicate as precursor, and these salt particles, they interact with each other by weak van der Waals forces or hydrogen bonds. So when a gel is formed, uh, the tetraethyl orthosilicate with the precursor which we have used, which is known as silicon alkoxide. So where there are OR groups, silicon and OR groups, or in silanols there will be silicon OH groups. So these groups, they interact with each other, resulting in the formation of a SiO-Si groups, which are known as siloxanes. So these siloxanes are formed by hydrolysis or condensation reactions where water molecule is eliminated. So these are the kind of reaction which happens and leads to elimination of water molecules. As a result, these metal alkoxide, they form precipitates. So this here we can see in more detail how these polycondensation reactions happen in the formation of a gel. So SiOR group plus water molecule, that is, this is a hydrolysis step. So you can see removal of one ROH group and SiOH is formed. So then next step is condensation in the aqueous medium. Then it is called as hydrolysis. Then if it is OR groups, it is called as alcohol condensation and alcoholysis. And then in the aging stage, we see that polymerization happens. So number of SiOH groups are formed, resulting in the removal of N water molecules. So this gelation, this is called as gelation or network formation. So here we have seen that it leads to the formation of an oxide or alcohol bridged network. And these number of reactions, condensation reactions, are known as polycondensation reaction, and this results in the increase in the viscosity of the solution. Okay, so the increase in the viscosity continues till the complete gel formation takes place, and that point is called as sol gel transition point or gel point, when a continuous network has formed. And a simple test for this is just turn your container upside down, and if the solution doesn't fall down, indicates that the gelation is complete. So here actually is what is happening is these large sols are converted into fine network, polymeric network, and then this polymeric network we can further treat under different conditions to obtain different types of nanomaterial. So this size of the nanomaterial, 1 nanometer, 5 nanometer, 10 nanometer, 30 nanometer, it depends upon the acidic conditions or basic condition. That means the pH of a solution, the water ratio. So if it is larger, then there is more water is retained. So low water ratio will ensure the nanomaterials, and high temperature. So these are the conditions which are required to form the three-dimensional gel network. Now in the gel, which is once it is formed, that network, a thick paste is formed, you need to allow it to grow for a day or two. That process is known as aging. If it exceeds 7 days, it may form cracks. So in during this 124 or 48 hours, lot of polycondensation reactions takes place, and the solid mass is converted into gel by removal of solvent and water molecules. Then further, it can be dried, and this drying process is a very complicated process, which brings about many fundamental changes in the structure of the gel. So the drying can be done, and you may get a zero gel, which is formed by shrinking of a gel. So there is shrinkage, and it forms by drying at a little higher temperature. So zero gels, they retain high porosity, 25%. Their surface area is very large, and because they have very small pore size, 1 to 10 nanometers. As against aerogels are against synthetic powder, synthetic porous ultralight material. So aerogel is a powder, aerogel is a foam like material. A very light ultralight material is obtained, because in this case the liquid which was there in the gel has been replaced with a gas, and without collapsing the gel. So without collapsing the gel, the you can see the gel is not collapsed, but the liquid is replaced with air, and hence we get a ultralight material. See, the very nice thin transparent ultralight materials are obtained. And then the dehydration and densification stage. During this stage, further rehydration is prevented by removal of these surface bound MOH groups. Okay, so if more MOH groups are there on the surface, it may get rehydrated, and this is prevented by dehydration, and it is achieved by heating at about 800 degrees Celsius. And here it is further densified, or if required, the gel may be decomposed at much higher temperature, which is greater than 800 degrees Celsius. Then the porous gel network is collapsed, and all other remaining organic solvents are also volatilized. And then, since the gel network is collapsed, it converts into a dry powders, that is zero gels. So here in this stage, we have in this video, we have learnt about the different steps, that is formation of sol, then gelation, aging, drying, dehydration and densification. So now let us look at the synthesis of nanomaterials using this method. There are many advantages and disadvantages of this process. So schematically we can represent it by this diagram. So here is our solution of the metal ions, which under hydrolysis and condensation gives a colloidal solution. Now this colloidal solution can be allowed to etch, that is the gelation, to form a polymeric network, and it gives a gel. Once a gel is formed, you may use it in the gelatinous stage, or you will allow it to dry under different conditions. So this gel under supercritical condition, if it is dry, we get a lightest ultralight material aerogel, as we have seen. So here the polymeric network is retained, so gel is not collapsed. Whereas if it is under certain pressures and temperature, if we allow it to dry, and polymeric network is collapsed, we get zero gel, which on further sintering, that is high temperature, we can, so on further polymerization, we can get this dense ceramic material, and this material can be converted into either ceramics, or it can be converted into powders, and then by dipping, spinning and spraying, or we can form different coats. So you may spin to get fibers, or coat to get thin films, or dip it number of times to give you dense films. So we see we can get different types of materials once we get that gel, once the gel is formed, we can get converted into different materials as we have seen in that schematic. Okay. So you may get aerogel, you may get zerogel, you may get gel spheres, or you may get nano powders, or you may get nanostructured layers. So the advantages are sol gel process is we can easily process it and get different types of nanomaterials which are highly porous. We can create composites by filling these pores during or after gel production, and then we can do this at much lower process temperatures, and hence many substances can be embedded into the gel structure during the synthesis step, and they can be easily stored and released in a controlled manner. We get monodisperse uniform particle size powders, and even organic nanoparticles can be synthesized by this method. There are some disadvantages. It is difficult to control synthesis and drying step process. Therefore, it is very difficult or sometimes complicated to scale up this process. So we cannot get large scale production of these nanomaterial by sol gel method. Moreover, sometimes the organic contaminants can remain in the gel during the aging stage. So therefore, purification is important challenge, and as a result of this cleaning step, drying, post thermal treatment, this process becomes more complex than gas phase synthesis, and sometimes desired crystalline shapes cannot be achieved, and thermal stability of the powder is also lower. So thank you for watching, and if you have any questions, do write to me at my email sugandha@somaya.edu. Thank you.